Hello and welcome back to another Out of Spec Reviews video. Welcome back to another Inside Magna video. It's a cold and windy day here in Michigan. We're just outside of Detroit because we're actually going to go inside of Magna's Technical Development Center and we're going to learn how they engineer, create, test, and even like dyno test electric motors. And we're going to be looking at their e-beam axle. Very similar, actually the same truck that we drove in the Upper Peninsula of Michigan where, I drove that electric GMC Sierra. Allegedly it was a GMC Sierra. We're gonna go see that in here again and talk about how they made it this time. Hey guys, thanks for having us. Really appreciate it.
Welcome.
This is gonna be cool. Can't wait to see everything you got to share.
All right, come on in. Let's go do it.
Will you join us at the inner workings inside of Magna Powertrain where this should look familiar to you. We actually drove this exact truck up in the Upper Peninsula where we drifted it in two-wheel drive mode, we launched it in all-wheel drive mode, we looked at how the vehicle handles sliding situations in terms of power transfer, front to rear motor, and of course I showed you under the hood, so I'll give you a little refresher. You have some power electronics up top, for example your onboard charger, some cooling situations, and then what we're going to do is we're going to go on a deep dive of all of this here, and then we're also going to go to an NVH chamber and an electric motor dyno, which is going to be interesting. But why don't you join me on the passenger side? I'll open up this door really quick and just show you how well integrated everything is here with this truck. It is pretty impressive, that's for sure, just squeezing around. You can see basically the interior is almost stock. You have your gear selector down here, that's right. You have their own HMI or sort of like an iPad type situation that controls the entire drivetrain. And again, the point of this truck is really a demonstrator for Magna's electric vehicle motors and inverters and everything. It's not that, we're gonna see this exact truck electrified in production. It's really to show, hey, these e-beam axles that basically will replace, I'll show you underneath the truck with one of the head engineers, are insane. And so you all seemed to love this truck when we drove it up in the UP. I said, we got to do more. And here we are. And you can see the gauges are all very similar. I mean, if you really want to know more about how this truck drives, I have a whole driving review of it. And it's just insanely fun to like slide around and do stupid stuff with it. So let's throw it up on the lift and take a look at how it's actually engineered, constructed, and how Magna made this thing happen. John, thanks so much. Nice to meet you.
Nice to meet you again.
And so you are basically in charge of all the powertrain stuff for North America.
Yeah, what I'm responsible for is I do regional product management for Magna Powertrain. So I really am at the forefront of our conversations with customers on future products.
Ooh.
So this was basically my project that I started from some input from customers, and it rolled into our innovation team with Ryan Shaw and his team, who you met up at Winter Test. And they're the ones that execute the hardware, execute other things. I took on some additional product management roles for technical on the vehicle build, but for the most part, I deal with advanced customer like trends and requests and items like that.
Yeah, so can you share, I mean, obviously you built an electric pickup truck to showcase electric, heavy duty, medium duty stuff.
Well, not only that, to show people what Magna can do. A lot of people don't realize all the products that we make for the OEMs and the automotive industry. And what we're trying to do is not only show to the world what we can do, but more so our customers, to give them an idea of a possible solution where there isn't one today. We have some benchmarking going on next to us here on a Rivian that we have, and that's a little different truck. I mean, just look at the size of it. And so we're into, working on some work trucks, really.
Yeah.
So that's what we did here. We went and took out the whole powertrain. Yeah, this is 2500 series.
Yep.
So 3/4 ton, a lot of trailer tow capability, a lot of payload hauling capability. And what we did is we just went through and took out the whole ICE drivetrain, right from the engine on back to the axle.
So you basically dropped axle, rear carrier, basically the whole thing.
Transmissions, engine came out, everything.
Yeah.
So what we ended up doing...
I hope you put it into something fun like a smart car and like had a fun project with it.
I actually have someone who's doing something really cool with an old C10 Chevy with
it. That's awesome.
So, but
all right, come on under here.
Yeah. if you get in here, it's really, you start to see. I mean, look, I'm like 6'1", and there's plenty of room here. You know, when you work on this, you can have the vehicle on the ground, and I can sit in here, and we did it one night. We were working on it to get it going. But you can see right here, this is our Generation 3 electric drive. This has got an integrated inverter. So normally the inverter tends to be like a bolt-on box of electronics, or
we see it all the time
remote,
where it's this
like
thing
we have.
like on the top of it.
Yeah, and you've got all the big, huge orange cables going
Yeah.
from that to something else. In this case, we integrated it right into the end of the motor. So that makes it really compact for packaging. And then we just have 2 cable lines coming in because we have solid bus bars connecting it.
Oh, neat.
The other thing that's nice with this, and if I have you sneak up through here, in this corner back here, we have a disconnect system and a park lock. So this front drive can not only do park lock feature and hold the vehicle in position during park, but if you're driving down the road and you don't need 4-wheel drive, you can disconnect the front drive, get some really range savings by not motoring this motor or having the inertia having to drag along, because you take the inertia effect right out.
And that's mostly because this is a permanent magnet motor.
That's true.
But you offer different versions, right?
Yeah, this is a permanent magnet designed and built by us, but we are in production today with Volkswagen on the ID4, which you got to drive up at Winter Test 2, and that's where we do an induction motor. So that's a secondary drive axle induction motor. When you kill the power on that, you're just spinning the inertia. There's no residual flux forces, where with a permanent magnet, there's always some residual flux forces, gives you a few extra newton meters of drag and everything.
Yeah,
So,
and the clutch disconnect is something that do you think most customers will go for on permanent magnet solutions?
we're having a lot of discussions with the OEMs on that,
Yeah.
and that's the reason. They're seeing that there's opportunity to gain some range improvement by
Yeah.
adding that clutch. They want the permanent magnet for that low torque, low speed.
Yeah.
But when you're at highway speeds and you really don't need it, weather's
Yeah.
good,
Yeah.
disconnect it, put it out of the way, and put that savings into the range for the
And
customer.
are you having those conversations where you're recommending primary or secondary axles on certain parts of the vehicle? Like,
Yes,
yeah.
we have both. So a lot of OEMs come to us especially for secondary axles.
Yep.
You know, that's kind of like our traditional business was secondary 4-wheel drives.
Yeah.
You know, we did the RDMs on all-wheel drives. We
'Cause a
did
lot of them will
transfer
have
cases on
in-house
trucks.
motors,
They
right?
have in-house capabilities. A lot of customers are doing that on their primary. I mean, they make engines, transmissions today, so they're looking at it as that fits to their core, but the secondaries is where it kind of fits to us, and we have a little better advantage too. We have a lot of controls on vehicle dynamics through torque manipulation or movement in the vehicle that we're been doing for 40, 50 years.
Oh, yeah.
And that's playing in, and you saw it when you got to drive this up in Winter
Yeah,
Test.
because
So,
you guys did 4MATIC, X-Drive, a whole bunch of different transfer case
cases,
systems for
yes.
this system's 4-wheel drive
That's
auto
right.
when there was a gas engine.
and we have the rugged off-road ones, Jeep Wrangler,
Yep.
the Rubicon Edition, the 4-to-1 low, we make that. So there's a lot of that, off-road capability that we're used to.
Yeah,
So-
pretty neat. And so, yeah, back when you were mentioning what we experienced at Winter Test to our audience, basically, you have a full virtual model of what's happening with the vehicle, essentially happening on an ACM or ECU.
That's
And then
correct.
if you get too much yaw, too much slip angle, you can then overspin the front axle with logic to pull you out of a slide.
That's right.
Which is
Yeah.
amazing. It's all happening virtually.
Which is actually far better than what we could do with some of our systems before, because you could take away torque, but it
Yep.
was hard to add.
Sure.
It was easier to take that away to give you stability control. Now we can add it and really change you from a rear bias to a front bias. And where you had to wait for maybe the rear axle to lose traction, and then you had that front bias. Now we can make that shift
can just
ourselves.
do it
So you really
real
have
time.
longitudinal torque vectoring
Yeah.
is what you're getting out of it.
Absolutely, it's just insane. So I guess, just specific to this project, you spec'd this again as a showcase truck, really.
That's right.
And so you had to power it somehow. So you found the third-party battery.
Yeah, we have a really great integrator. You can see, if you can get a shot up here, up above, should open the hood, you will see all the accessory drives. So you got the DC onboard charger, the coolant pumps. You got one circuit for the battery cooling, and another circuit takes care of the electric drive cooling. You also have an electric AC compressor and a PTC heater.
Yep.
So, and then that comes down and you got your whole big skew of high voltage orange cables here coming out of the battery system, because we have 2 electric drives, plus we have a high voltage for the accessory drives.
And in this particular one, are you pulling the high voltage for the rear axle out of the front of the battery pack?
Yes, all the output, the battery has one
bar, basically.
IO distribution bar,
Yeah.
in front. And
But in a production vehicle, you would never want to do it this way.
well, it could be. It depends on how they construct the battery, where they put the BMS, and how their bus bars are.
Interesting, yeah.
So it's really a lot of that's packaging. That's
Yeah.
that's one of the things you see why the OEMs take it on themselves. They're designing the platform, so they're doing the packaging.
And it's about an 85-ish kilowatt-hour battery in
That's
this
correct.
one, but
Yes.
no relation to any
No,
production specs.
it was basically, we had to work within the frame rails of the vehicle. We
Yep.
did a lot of adaptation here to mount this battery up in place. What you can see here is these larger aluminum plates are cooling plates, so this is just conductive cooling from the cells through the casing to these cooling plates.
But
and
it's
then,
also actively cooled, right?
no.
Oh,
it's
this
all
one's just a fresh battery. Yeah, just blocked in.
Blocked in,
Yep.
conductive cooling, and then you have the support structures are the smaller plates here.
Yeah, I got to say, I'm surprised it didn't have any active cooling, because we really drove this thing really hard.
Yeah,
And it
yeah.
didn't thermal throttle on us.
No. Well, it was cold then too.
Yeah, that's right. It was a really freezing
we'll
cold
see
day.
once we get to the sand dunes this summer
You start
what it's going to be
dropping
like.
it on ice.
Yeah. So, and then that comes back, and then you have finally our E-beam, what we put in place. And as we, have touted, we did a lot of work on research on different type of suspensions. There's basically 3 types of suspension: the Hotchkiss, which is what you see here, leaf springs to a solid beam. There's what's called independent, which the Rivian and other like Teslas have, and that's where you have a unibody construction, not body on frame, but unibody construction, and you'll have a structural cradle that gets mounted up, and then the electric drive will be mounted
And
in
it's
that
just
cradle.
fixed.
And it's just fixed. That's similar to what we have in front. We
Sure.
kind of made a cradle there for that. And then you go to what's called a Didion, which is like a cross between the two. It's has a cradle, but it's set up with an independent drive, but then it has, instead of wheel hubs going out, you basically have a stub axle on the side of it. So you have
interesting, yeah.
you have a half shaft or drive shaft between the electric drive and the stub axle, and then you go to a stub axle. And you see that a lot in Europe, and it allows you to take that heavier payload capability too. But we did a lot of study, and we said this is the most economical for everyone. And when you look at what we did here, these springs, standard, the mounting, standard, the bump stops to the axle are all standard. The shocks, these are the original Rancho shocks that came with this vehicle. We kept them all in, so everything's 100% carryover on the suspension here. So
And that's
that really
really-
makes it for a nice drop in.
Yeah, I mean, it's super important because, to show, I guess, you're pitching clients with this truck, basically.
That's
And
correct.
you're like, oh, we already make this. You don't have to do any adaptation other than slap in this whole
That's
axle.
right.
And
And
how
that's
do-
one of the reasons we chose. You can see here, this looks very round here, but when we get to the backside, you'll see this is what's called a coaxial layout. The motor and the gearbox,
All in
input
line.
and outputs are all on the same plane. So we just have a little bit of reduction that sticks out on the backside here. But otherwise, that's what makes it really tight. That we actually, I think it was about 30 millimeters more ground clearance we were able to give over a standard axle. And then when you think about the weight, the standard axle out of this weighed 186 kilograms.
Okay.
This right here, this E-beam in its configuration with the inverter is remote on this particular case, was 215 kilograms.
Yeah, so not much difference. I mean, you're
Not
certainly
much.
giving up some unsprung mass, but then also like you're removing a whole bunch of crazy
Yeah,
drivetrain
and I
components.
added a lot of batteries,
did
so
add some-
the
yeah.
ratio is almost the same.
Yeah.
And when you look at it, I have not only a motor here, I have a transmission, and I have the differential of the axle all in one, where you had that spread between the axle, the drive shafts, the transmission, and
Oh,
the
sure,
engine.
yeah.
So for, basically I'm looking at 30 more kilograms of mass. I got everything in one package.
Right, and just the response time, there's less slop, there's less slack,
right,
and
yeah.
it being electric, you just I mean, I drove this truck. It was the coolest thing ever.
Yeah,
to
the
be
torque,
like in a heavy
square
duty
wave
truck.
torque curves.
Yeah.
Just launch it really quick.
Yeah, it's pretty impressive. And I guess what was the decision to go with a remote inverter? Because you also had to develop this cabling and everything as well.
Yeah, we did a lot of development work on the cabling. We actually set up a rig and ran it through a couple 100,000 iterations.
Oh, really?
Of vibrations,
yeah, that's cool.
Just to make sure it worked. But really what it came down to is we started on this program. We weren't really confident at the time because we didn't have the knowledge of could the power electronics survive in the environment on axle suspension. And since that time, we did a huge amount of instrumentation, accelerometers, shock loads, finding out, basically taking those vibration traces and then taking our inverter and mounting it on a vibration stand and running that signature that you saw in the vehicle.
Yeah.
And then analyze the solder bonds and the chip welding bonds to the board and made sure that everything could survive and no problem.
Wow.
We got a green light on that. So
this is
right
not going to
now,
happen anymore.
Ryan's team is developing the second generation of this, which is going to have an onboard inverter.
Cool. So when eventually you sell to a customer and this goes into production, it will have a mounted onboard inverter.
That's correct.
But you could also have the option to not.
That's right. You could have the option to not. The thing it saves you is, when you look at high voltage cables like this, you got 3 cables in there. You have 2 connectors that are very, expensive. Plus you have some strain relief brackets. Now you'll just have one come in with 2 wires instead of 3. They'll be a little bigger, but it saves you a lot there. That's cost for the OEM.
Yeah.
It also eliminates some warranty too at the point. So
that's pretty neat. And can we take a look at the gear reduction? Just bulge on the back, I guess, is how you would say.
Yeah.
Yeah. Just
so
this right here.
Yep, right here you can see. So we call this an out and back because from the motor there's a input gear here that goes out to the first stage reduction and it cuts across, and this is the final drive stage reduction right here, and the differential would be right here. So you come out with one reduction, it comes across the shaft, goes back with the other reduction, and then you finally have a differential that puts out the power to both sides.
Yeah, well, it definitely is a strong unit because I drove the heck out of it. I was impressed with that.
And as you can see, it's a bit dirty. It was at the track yesterday.
Yeah. Oh,
we
nice.
had a customer there. We were doing demonstrations.
Perfect.
And we have more going on. And we've just been waiting for some of the state parks in Michigan's really good with off-roading.
Yeah.
We have sand dunes on the western side of the state. We have an off-road park about 25 miles north of us here.
Yeah.
And that's where this thing's headed next. We have a number of objectives that we have to prove out for our project that we had here.
Yeah.
And that's where we're going to be heading
Oh,
next.
that sounds like a good time for sure. Well, thanks for showing us the truck. Really appreciate it. That
Thank
was
you very
super
much.
awesome. So we're leaving the Intelligent Force behind because we're going into some sound chambers. And you guys know we talk a lot about electric motor noise. For example, the Rivian over there, we've commented the motors sound amazing and different, but they're really loud and they have different frequencies and things that come in and out. And this is where we find out essentially how this all works. Ricardo, I'm Kyle.
Nice to meet you,
Nice to
Ricardo
meet
Rivera, MVH manager here at Magna.
So as NVH manager, you can tell us everything our audience wants to know about sound with electric motors, because we get, I don't know how many hundreds of comments every day about people wanting to know what's generating the noise. Is a car loud on the inside? So maybe you can talk a little bit about testing first, your chamber here, and then what's actually creating some of the sound.
Absolutely.
Cool, thank you.
So what you can see here is our semi-anechoic noise and vibration dynamometer. So typically we test transfer cases products, also axles, things like that.
So that's what this is here. This is a transfer case.
This is a four-wheel drive transfer case.
And
that is correct.
And it's for a production unit or or is it a prototype?
It's for production.
Okay,
it's for production.
very cool.
So what we take here as far as data goes is vibration and sound pressure level. Vibration is recorded through the use of accelerometers. As you can see, those are attached to the unit under test.
Yeah, come on in here, Timon, so you can see a lot of this.
So accelerometers are these guys here. There's another one underneath here. We have a specific microphone array that is dictated by our customer requirements.
Mm-hmm.
So
the customer will say, hey, we want to know what parts of this is making noise, and so they say, here are all the angles.
absolutely, absolutely. And this is exactly what you are seeing here. All of these microphones are on the near field side of things. which are like 100 millimeters away. We have also far field microphone on top of the unit,
yeah.
right at the split line,
What is
1
this
meter.
one all the way at the top? Is that a microphone?
That's a microphone as well, but that is not for data purposes. That's just for our technician to listen what's going on.
Okay, nothing fancy for
Yeah,
that one
exactly.
then.
In case something goes wrong.
In case you get locked in this thing or something.
Exactly.
You're like,
So
yeah, let me out.
Exactly. He's going to be able to listen to anything that could go wrong, things like that.
And what exactly is the chamber made of? Now, there's no soundproofing in the floor.
Correct, correct. As I said, this is a semi-anechoic chamber.
Yep.
The reason why it's semi-anechoic and not fully anechoic is because on the ground, we don't have any MDH treatment, which means sound can still, sound waves can bounce back to the air. But on the walls and ceiling, you can see these wedges that are made out of perforated steel. And behind that, there's insulation, like fiberglass insulation, that is used in order to absorb noises and
It's really wild just even standing in here.
Sure, absolutely, absolutely. So
it just feels weird.
if you were to close the doors here
Yeah.
and just stay here like for a minute, you will start to feel a little bit.
Like sick a little bit.
Exactly, exactly. It's a weird feeling, but
It is amazing just how there's almost no reverberation.
correct, correct. But typically we use this tester whenever we are working on serial development, or even if our current production design is changing for some reason.
So you just put it in here.
We'll need to validate that those changes are still meeting the customer expectations and customer requirements.
And so I saw that if we go on the outside over here, there's an electric motor that to spin, I assume, the transfer case in this case.
Correct. Actually, this is a 3-motor dynamometer setup. These dynos are simulating these are absorbers. This is simulating the rear axle of the vehicle.
Oh, okay.
If we go to the other side, we have 2 motors here. One is simulating the input side of the vehicle or engine transmission kind of thing.
Yep.
And then we have another one that is simulating the front axle or front output.
Oh, very interesting.
The good thing about this dynamometer is that it's not only good for transfer case products. As you can see, in this area, there's an opening that currently is closed.
Yep.
But we can rearrange the dynamometer layout in order to have a motor in there and be able to test axles or rear drive
Right,
modules.
so you could go full axle, so you could have a drive shaft coming in, spinning, and then a left-right output then?
That is correct. That is
Yeah,
correct.
that's cool.
So
And did you guys build this yourselves, or did you just buy this thing, or how did you adapt this to your needs?
actually, we put together years ago an SOR to different vendors, and we selected one of those vendors.
And they built this to your
Exactly,
specifications.
exactly.
But look at how thick this door is. If you come around here, I mean, that's just the level of soundproofing. Like, this is my hand, just for reference. It's crazy. So cool. And yeah, I just can't get over stepping in here. Yeah.
And one other thing that I wanted to mention, within the MVH activity type of development that we do over here,
Yeah.
from time to time, we also need to localize sound areas radiating from the surface of the products.
Huh.
This is an acoustic camera for sound localization.
No way.
So you can see the tiny camera is here,
Yeah.
and then there are 81 microphones within this circle on the arms.
Oh my God.
So what it'll do, it'll take a snapshot of the unit under test, and based on the data that is being recorded through the microphones,
Give
it's
you a
gonna be,
visual.
yeah, it's gonna be like a color map. So it's gonna tell you this is the most active area, this is the less active area, and with that type of information, we can always go back to our design team
Yeah.
and tell them, you know what, maybe there are some areas to improve because there's a lot of noise radiating from this particular area.
That is
So-
amazing. And I guess more to our application here, talking about electric motors.
Correct.
What makes noise in an electric motor? Obviously, you have gear train, but you also have electric motor noise. So what parts are you looking for?
So there are a couple different things. I mean, we have noise that could be coming from the, as you said, gears or rotating parts, but you also need to take into account the electric field, magnetic field, those type of things, because those also are going to generate specific metrics that could be annoying to the people or
Yeah,
end
these
customer.
high-pitched screaming
exactly,
noises.
Exactly,
Yeah.
exactly. So just to for you guys to be aware, this dynamometer is for the traditional side of things business, like ICE,
Yeah,
transfer case,
transfer
axles.
case, yeah.
We are getting prepared to build a brand new quiet dyno or noise and vibration dynamometer
Yeah.
for electrified products.
Oh, really?
And next year we should be able to start testing those, like the EB Maxel that you guys
Yeah.
tested.
So
the other
when
day.
we come back in a year or so, we got to throw an electric motor on there, crank it up, and see what it does.
Correct.
Yeah,
correct.
that'd be really fun.
And that'll happen at the other end of the building.
Oh, really? Cool.
Yeah.
So that'll be a totally separate
Correct.
section.
Correct.
That
correct.
is cool. Well, Ricardo, thank you so much for showing us
Not
this.
a problem.
Do you, I guess, just in closing, do you see any challenges in, I guess, benchmarking NVH of electric motors? Like, does the electric field affect microphones at all or anything like this?
Well, it's definitely a different animal
Yeah.
from traditional side of things. And every OEM out there, they are dealing with their own issues as far as electric motors goes.
And I guess it's like, because it's still a new technology, I mean, with a transfer case, you've kind of honed in on what everyone's looking for.
Correct.
But maybe with an electric motor, this customer wants to know about these things, this customer wants to know about that.
Absolutely,
Yeah,
absolutely.
it's just a little all over the place.
Absolutely, and customers are still trying to figure out where those requirements are going to
Yeah,
be. So.
cool. Well, thank you so much. This was incredible to see. I've always been curious about this type of stuff. You would never think that individual driveline components of a vehicle would have to go into a chamber like this and be totally evaluated in terms of noise performance. It just shows that our little silly decibel meter in a car is so lacking in terms of quality.
Correct. There's a whole science behind it.
Yeah,
so.
yeah, of course. Well, thanks again, Ricardo. I
Not a problem.
appreciate it. That was great.
You're welcome.
So
right.
what exactly is even in here?
So we have a prototype machining for our prototype parts.
Oh, neat.
We focus on gear manufacture because we're a gear company.
Yep.
And to control lead time and quality on prototype gears and be able to do design of experiments around noise of prototype gears and control our forms, we choose to do that ourselves right
And
here.
can you do gears for your electric motor stuff as
Absolutely.
well? So how do we get in here to see all this?
Come on along.
All right, let's do this. So I can see giant CNC machines and like other water jet stuff. Like what do you even have in here?
So that's a single flank gear grinder. So that's the final. So after it's hard, that's where you finish it.
Yep.
So we have a Gleason Genesis that we'll cut it on.
Okay.
We'll send it out to heat treat because we don't do heat treat here. So we're divided into two sides. You know, this is basic machining for fixturing and stuff we need. Everybody needs to be able to nip, tuck, or modify.
Sure.
And then we said we do prototype gear manufacturing over here.
Yeah,
In
this is
fact,
cool.
We can EDM a gear for you if you like, or a spline in a wire EDM.
Really? And so this is where you have your wire coming through then?
Yep. And program it right in and cut a gear, a spline, or anything else.
Wow.
This is one of the coolest things. I think this has had more payback than any other machine we bought.
Really? So you guys use this a ton then?
Oh yeah.
That's pretty amazing. And then this is your control software built right in. And how old of this is this machine, would you say?
3, 4 years? 3
Yeah,
years?
so pretty new, pretty fresh.
Yeah, and the tolerance thing's amazing. You know, so Johnny says he can cut it, two like microns,
Sub-micron.
and then we take it across and they can measure it to a micron. And how am I to tell them no? I don't know.
Right, yeah.
I can't look at it and tell them.
That's pretty amazing.
Yeah,
That
it
is
is.
so cool.
So we got wire.
How's it going? Dang.
Shaper cutter that we don't have running, but it's a way to make a gear.
Yeah. Dang. That's some serious freaking hardware.
So we
right
have
here.
input shafts, they're about so long, so we need that stroke sometimes. This is purely based on stroke. That we got to cut a long spline,
Gotta have the room.
got to have a piece of equipment.
This one's the Viper 500WE. That's my favorite, by the way.
So this is a Klingenberg, and you dress the grinding wheel, and it's a single flank grinder. You wouldn't do this in production, obviously, because it would take too long to
Sure,
generate
but
that
for
gear.
prototyping, you got time.
Yeah, we got time. We want to control quality. We might want to make, you get asked the plants. Sometimes we like to make gear forms that can't be manufactured because they seem to be the quiet ones.
Sure,
And
yeah,
then you
yeah.
got to figure out a way to make it. But, we'll do that sort of.
That's really freaking cool. And just look at all the buttons and controls and little tiny things you can input here to make your output. Like, the tolerances on this stuff is really crazy.
Yeah, and we hold tighter than production tolerance in here because we
Yeah.
want to test the ends of the spectrum.
Sure,
right?
sure, that makes sense. Well, thanks for showing us this room. This is just insane.
Yeah, it's like I said, it's critical. Noise is critical to our product. Controlling gear form and understanding, the results is very important.
Yeah, yeah. Yeah, this thing is really freaking cool.
Take a look.
Man, I wish we had this at the office.
All right. So we'd walk by our build room. Like you said, we can't go in there today.
Can't go in there, but you got the old View Sonic with the touch
Yeah.
reader here.
It's so there'll be, we have a stand-up meeting, right? And they go through the list of prototype orders, what they're working on today, where everything's at, and the team would stand up in the morning and have a meeting and go through their priorities.
That's pretty sweet.
Well, now we're upgrading, like I said, all of our building technology. So
Yeah.
it is pretty cool. We have
Yeah.
everybody together, and what are we doing?
So you're doing a lot more virtual conversations.
Yeah, well, we have to do some, well, these guys aren't, you can't machine parts virtually, so the back shops, you may have a manufacturing engineer or somebody call in, but for the most part, it's still a stand-up meeting instead of a Teams meeting.
Right.
It's our inspection lab. We have full service, geometric inspection as well as metallurgical. So, it's, gear checking or CMM.
It's just insane. And so these tables, I guess,
Standard layout, just a granite table if
Yep.
you need to do a quick height
yeah, just
setup.
a granite table.
Oh, yeah.
You probably could have gotten away with that much granite, but
that's
no,
just stable. You want it to be stable and
Right.
certified because that's what they're held to.
Yeah, that's pretty amazing.
And then, like you said, the metallurgical, so we can do mounts and checks right on site.
Oh, yeah.
And
Cool.
actually have a scanning electron microscope too. And it's good to have it because if you have a failure on Friday night and your customer wants to know answers right away,
Yeah.
you
Then
need to have it.
Yeah. And have you had to do that before?
Oh, yeah. And it's always Friday night.
It's
So generally about 4 or 5 o'clock, but it is. It's always Friday night. Yeah, take a
oh,
look.
sweet. So this is going through and
That's
measuring
actually your
the-
gear.
Yeah, so this is the high-speed mesh, so this is the bigger gear, so the rotor shaft actually mates with that gear itself. So that's the first reduction in our E-beam.
Yep. So this is part of the E-beam strategy.
So that's checking the tooth geometry.
How long does it take to do the entire 365 degree?
It's a big gear. You know how long?
Yeah, it depends how many teeth you're checking, but so this is actually attached to the gear grinder, so you can actually output the data from here to the grinder to make corrections.
And then make adjustments based off of that. That is pretty neat. Is it the same company who makes both?
Exactly.
So it's a part of their system that they allow that. That's really cool. Wow.
On the CMM over here, we have the water jacket for our electric machine. So the EM
Oh,
actually
yep.
is pressed into there, and that goes into our housing.
Right, and this is for cooling.
Correct. Yeah.
Man, looks like you could launch some serious weapons with that thing.
These are cool machines.
Yeah, they are
They run on
wild.
all air bearings.
Really? Oh, so the vibrations don't come through at all then?
Yeah, very precise. And the tips on the measurements are actually little rubies.
Little rubies.
Yep.
Is that why they're red?
Yep,
They're
exactly.
actual rubies?
Yep.
Wow.
Industrial rubies.
Industrial rubies. I like it. Well, these are bigger ones over here. Time to take a look at those rubies.
Depends on what you're measuring.
Yeah.
It's part of the thing. You just put a bore mic in a bore and call it good, and now we take thousands of points.
Yeah.
So this is our functional and durability test lab. We'll go down to the, we'll start in the
So
dynamometer.
functional durability and test?
Yeah, so a lot of functional tests. We'll show a lubrication test in a few minutes.
Yeah.
But, more function rather than durability.
Yep.
In these sort of stands, we do clutch testing to make sure that if I want 2,000 Newton meters, I got to make sure I'm getting 2,000 Newton meters.
Right.
So.
And will clutches and disconnect functions need to be replaced at some point, or they're lifetime products?
It's an interesting thing. So if you can speed match, you don't seem to need a clutch.
Right,
to
but
bring
if you
up
have
the
a
front
huge
output.
if you have a
But-
change of speed and you can't quite get it, that's why there is a clutch and it's not just junk. So there must be some wear on it.
Oh, for sure. We'll do
Yeah.
a durability test, but this is more to check if I get one back from a customer test, is it still accurate?
Yeah.
What's the customer test under the clutch and verify the product.
This looks insane, just peeking
Yeah,
through.
I guess turn you over to Ryan probably and bring out and introduce Larry.
Cool. Ryan, I'm Kyle.
Nice to meet you.
Nice to meet you. Behind the camera is something truly insane looking.
Yeah. Yeah, so this is our dyno setup for our E-beam. It's quite the achievement to get this set up here. As you can see when we go in, there's a lot of different components to mimic the vehicle setup for dyno testing.
Now, I'm very familiar with combustion engine dynos or chassis dynos. How does a electric dyno differ?
Well, so traditionally we have 3 motors, one simulating the engine and then the 2 prop shafts because we do a lot of transfer cases here.
Yep.
Now that we're down at the axle, we are the engine, right? We have only 2 motors now, so the 2 absorbers are mimicking the wheels. So they're actually providing the resistance for the...
So you can do regen testing.
Correct.
You can do power testing.
Yep.
What do you do with the power that you regen? Do you burn it off as heat, or does it go in somewhere?
I believe it goes back into the system. Yeah, there's a bunch of wires up here.
Oh,
On the bus.
it really goes right back in. So you're not wasting that energy. Because I've seen, we have in our office some small scale electric motor dynos, and then we just have resistors that burn them off. But at least here you're not letting it go to waste.
That resistor bank, you put it right back on and draw it back.
That is cool.
Yep.
That's
So-
awesome. So can we go in?
Yeah, I believe so. I don't think
Okay.
It's not running. Nope. So we'll start off with the power source for the EM. This is our battery simulator. This one's capable of about 250 kilowatts.
Okay, so that's a pretty serious output
Yep.
level then. I mean, and is there a battery component inside of here at all?
No, so this is taking the AC power that powers this whole area and
Yep.
converting it back to DC.
Okay,
So, yep. And so you can set everything from voltage, current, and power. There's actually a lot of different things you can do with this unit. You can actually make it mimic a battery, so you can give it a state of charge and actually like drain it down. Different
right, so you
things.
can simulate voltage sag under load and
Correct.
things like that?
Yep.
That
Or you
is
can use
cool.
it as a large power supply.
Right.
Yep.
Man, and it's made by AeroVironment. I know
Yep.
some of those guys from back in the day.
I believe they got bought out by Webasto. but
Yeah,
yeah.
I think so. I think so too. So this is a pretty old unit then.
This is a little bit older, but they
Yeah.
still sell this exact same unit. I talked to them maybe 8 months ago.
Oh, neat.
I think the new one has a white housing.
Oh, okay. Well, that's worth the upgrade.
Exactly.
So there's just like cables and wires and stuff everywhere.
Yep.
And you also have a ton of sound paneling throughout the
A
room.
little bit, yeah. So this isn't quite anechoic, but
Sure.
it's more to deaden it back into the rest of the building.
Just because with this concrete or these blocks, it would just be really
Exactly.
loud in here.
Yep. So yeah, you can see the wires coming out of there.
Yep.
Come over here and go all the way back to the back. So that's providing DC power to the cabinet back there.
Oh, interesting.
Yep.
Okay. So this feeds the power back.
Yep, or into the system. Yep.
Yep.
And so yeah, as a battery simulator, it can draw and accept power.
Right.
Yep.
And so
So-
here's the E-beam.
Correct. Yeah. So I guess just following the whole flow of things, they go into that cabinet, and then we have our DC cable coming out into the back of our inverter right here. So this is a remote-mounted inverter.
Yep, just like we saw on the truck.
Exactly. Yep. This is almost the same configuration as the truck. I think it might be a little bit higher right now, but so yeah, our inverter right here, and then we have our AC cable coming down to our axle into the EM housing.
Right, and so you have drum brakes here.
Yeah, so this is actually one of the axles from the vehicle, so it's a spare unit, so it
Oh,
does have
okay.
everything ready to be swapped into the truck.
Oh, really? That's
Yep.
pretty neat. And so you can go up to 250 kilowatt out and in.
Correct. Yep.
Ooh, that's cool.
Depends
And
on your regen strategy, but
then these will drive the motor.
so these are actually absorbing. The
But when
power
you-
source is the motor.
But what happens when you regen? Like-
Correct. Yeah. So these would be spinning and providing the torque back.
Okay,
into it.
right.
Yep.
So for regen testing, these provide power. For power out testing, I should say,
Yep.
then these are creating a resistive load,
Yep.
and then you're piping that energy back into this.
Yep.
So there's only a few % of loss when you run this thing.
I'm not quite sure, but yeah, I believe so.
Yeah, by the time you convert it back, I don't know what
Yeah, maybe 10 or 20% loss, but
Yeah.
it's not like you're just burning 250 kilowatts to run it. That's cool. And what's all this behind you here?
So this is the input motor for our three motor testing. So
Oh,
this is
so-
not required.
For electric stuff.
Correct. Yeah, because we're right on the wheel ends here.
Right, and for 3, the reason for 3 is because a transfer case has 1 in, 2 out.
Correct. Yep. So we're an axle.
Or if it's really exciting, then you have 3 out, which I don't know what you would need that for, but
Yeah. And then we have the other aspect of this, so kind of mimicking the vehicle. We have a full coolant system to provide cooling to both the inverter and the motor itself.
oh, interesting. So that's what all this is here.
Yeah, so it starts over there in the tank. We have an electric pump right out of the truck through some sensors into the inverter. There's quite a bit of heat there from the power module itself.
Well, this one can rapidly heat, right?
Yeah, so the power module itself is the highest concern because it can generate a lot of heat very quickly.
Yeah.
And then it comes down into the motor. You saw the water jacket before.
Yep.
Comes around, goes through this little heat exchanger right here and back into the system.
And can you cool to sub-ambient with this system? Do you have a chiller on it?
Yeah, so that's actually what these blue cables are here. There's a
Oh,
large
okay.
water tower on the top of the building.
Oh, really?
Yeah, and so that's providing cold water.
Cold water,
And you can drop the temperature.
Except in the summertime, it might be warm water.
It's still pretty cool.
Compared to what this is, it's all going to be.
It's a much
pretty-
larger heat exchanger up there than
Yeah.
what we have right here.
Yeah, that is really neat. Would we be able to kick it on when we're in here, or do we have to be completely out of here?
Yeah, we can't turn on while we're in here, both
bummer.
due to high voltage and spinning components.
Yeah,
Yeah,
no problem. Don't want this exploding in our face.
exactly.
Yeah, and look at these freaking connectors over here. So how much power do you think that thing can do?
I think that's a 480 plug, I believe, maybe higher. So that's actually powering the little environmental chamber behind you. And then the cables you see on the floor are the ones for the three-phase for the
One of
motor.
these motors takes
Right.
3 of those.
Takes 3 of those.
And in a bit, I'll show you where we get primary power.
Yeah, I'd
And
love
if
to
you
see
look
that.
at the top of the pole, they're only that big.
Just because the voltage has stepped up. Yeah,
It's amazing to
Yeah.
me.
it's crazy those little things can just juice that hard, but that's pretty wild. Cool. Well, thanks for showing us this.
Of course.
So how many dyno rooms do you actually have?
So we have 4 here.
4 of them,
So
and
this
they're
is-
all identical to this?
So this is the newest and the biggest.
Right.
But then we have 3 more. The 2 at the end are very similar, and then this is the smaller one.
Everything's a little bit different depending on when we
What
purchased it,
configuration
what
and-
product we
yeah.
purchased it for at that point.
Makes sense. Well, thanks, guys. Appreciate that. Carl, I'm Kyle.
Nice to meet you.
Nice to meet you, sir. So what is it your responsibility here?
I'm one of the dyno technicians responsible for validating accelerated durability testing. Anything we build here, we validate through 3-motor product testing.
Yeah.
What we're running right now is just a production Audi rear differential. It
Okay.
basically, the customer gives us data in the form of a text file, say. We take that data directly, import it in here, so exactly what the vehicle does on the road is what we are
You
simulating.
can simulate
Yep.
the exact loads that are on it.
Yep. The benefit to this is we can actually take the useless points of data, starting and stopping or just cool downs. What would normally take 700 hours, we can do in 200 hours.
Oh, really?
That's the benefit to these machines. They accelerate testing. So, a 6-month test in a vehicle will take us 5 days on
Wow.
a machine because we don't run out of gas.
Right. You could
We
just
don't
let that
overheat
sucker
anything.
go.
Yes. So, we
And
really,
what are those tubes that are pointing at the transfer or the rear
That
axle there?
is, we have blowers on the roof
Okay.
of the building.
Just providing airflow?
Whatever the ambient temperature is outside, we blow in on the unit, and it is controlled by. It's completely automated, so we tell it to maintain a sump temperature of a specific degree, and they come on and off as needed. They're dynamic.
And then here's all of your RPMs and your torque loads on everything then?
Yep. This would be the engine.
Yep.
And then you have the left tire, right tire. So basically engine, left and right.
Wow, that is
Yep.
cool.
And his speed, TS is torque. So it's just, and this is the live screen oscilloscope just so we can see if there's any, we can tell if a shaft's starting to go bad, you'll have some overshoot or it's not following what the command is. So.
Sure, that makes sense.
Yep,
Well,
very
that is
helpful.
cool. And have you done any work on the electric motor dyno stuff yet?
Absolutely, yeah.
Yeah.
We did the e-beam that's in cell
Yeah.
4. I did all of the validation testing from October to December.
Really?
Trying to get it ready for winter tests.
Yeah,
hopefully.
well, I loved driving the truck during winter test and was just blown away by it. So thanks for all of
really
your
cool
hard work.
technology. Yeah.
What
no
are,
problem. On this, yes. So we also have in the background, it's a knock sensor that can track order as it learns how the specimen's performing. It will actually shut you down if it detects any type of wear. It through order tracking, gear mesh, bearing race profiles, and all that stuff. It'll
Yep.
yeah.
So before it gets catastrophic.
Yep, that's what that is. It's an early detection system.
Yep.
And it just uses a basic engine knock sensor, and
Wow.
the software is very, very powerful.
And when you're dyno tuning an electric motor, just out of curiosity, what are some of the wear items that you're seeing with that? Are you looking at thermal performance over a period of time in terms of heat generated, or is it more componentry of the gear train system on it?
In this case, it was more thermal. Just basically, it's new technology, so we were unaware of how it was going to perform. So
Sure.
we put it through the max power and peak of the motor curves, and Yeah, you realize how hot stuff gets with electric.
Yeah, very quickly too. Yeah.
Yeah, we didn't. We basically, they were called BAT tests. What we were doing for, it's a build assessment test. So we're making sure that it'll hold torque, it doesn't overheat, all the electrical components work properly. And we did one gear test, but it doesn't really test thermals out. It just
Right. Just make sure that they're all connected, basically.
Yep.
Cool. Well, thank you so much for the tour. Appreciate it. This is really an awesome job you have.
I love it.
I would kill to have this
I
job.
get to
This
break
would be,
stuff.
I know,
for
that would
free,
be
yeah.
insane.
You can even log in from home and see it.
Oh, really? So so
phone app, I can see if these things are running or not. And
so what are you even doing here?
good question. Yeah, gas is almost $5 a gallon.
Right, yeah. So, but actually though, there doesn't need to be someone here monitoring it because this can shut it down if it detects an issue.
Yes, but you still need, so it is, I can't tap into this. I can only tap into the camera system.
I see.
It is illegal to have control of this system when there's no one here watching it. It's highly illegal because you hit the wrong button and I can send that thing flying through the ceiling. So there always needs to be someone on this end that approves a connection.
Yeah.
We get guys, because the software is based in Austria, we get those guys plugging in to help us out with stuff. Yeah.
So do they use similar software at your Austrian counterparts as well?
Oh, absolutely. That's a KNS system they use, and this is an AVL system. Yes, they use these just like we do.
Cool. Well, that's awesome. Well, thanks for the tour. I really appreciate it. That was
Thank you.
awesome. So what are we looking at here?
So this is our lubrication test stand. So you can see that it can pivot in any direction, provide any...
So if you're on like an incline off-roading, for example, or off-camber situation?
The only thing we get in is customer specifications. Sometimes, at what max angle are you really going to do 60 miles an hour?
Sure.
So you try and develop a profile
NASCAR
on a
track.
matrix. Exactly. We're not running NASCAR.
Right.
But in a four-wheel drive system. And you can see, we have a clear housing.
Yep.
Because we can see on video as well as look and observe. We're certainly developing our analytical tools and just getting to where we can predict splash as well as vent location.
And this is for the transfer case technology.
Yep, this is a transfer case
Have
right
you
now.
put in an electric motor on here yet for the water jacket stuff? Is that needed, or is that just sort of closed loop, everything is being touched all the time?
We've done more of that as a system level, and we don't really have a setup to do a whole system for this size of product yet.
Right, but
So
still
we're doing
transfer
more and
cases
more.
are like just need lots of cooling. They need lots of water to go through
Correct,
everything.
and if you're coming uphill or
Yep.
downhill, do you starve something? Or, like I said, you're going in Moab, and we've got to be able to make sure that you don't starve anything from lubrication.
Sure, of course, especially as you guys do them for Jeep stuff.
Yeah.
So could we crank this thing on and see
Yeah, you
what
wanna
it
get
looks
up
like?
here? We have a lot of, if you're rock crawling in low range,
Yeah.
it's fairly slow. You want to make sure you get lubrication in that condition. And you can see as you come up to speed pretty quick,
Then everything just gets covered.
It'll covers the housing.
But if you can design it in a way poorly, right, where you can actually have so much pressure that it can skip parts,
Yeah.
in a sense. So you need to really
Well,
balance.
we're trying to get the right, this has a pump. There's some we have pumpless.
Okay.
So how do you baffle and direct, that lubrication down into the shaft, the bearing, the low range, to make sure that you have proper lubrication.
So what's the fastest you can spin this thing?
What's this, 10,000? 3,000.
Let's see what 3,000 looks like.
Bring her up a bit.
There it goes. Ripping. So that's simulating highway speeds or faster.
Correct. And if anything, now you starve the pump, you got to be careful.
Sure, of
You
course.
still want to have some in the sump to suck.
Right,
And you can see it's starting to get pink because it's aerated.
right. Cool. I like it when we start getting nervous, we're pushing the limits. Why is it so cold?
Sometimes, usually minus 40 is our coldest
Yeah.
requirement. So we
Yeah.
have to have something. It takes quite a bit. Your standard freezer isn't going to get to minus 40.
So will you freeze one of these and then throw it on there and see how the liquid performs at
So
cold
if you
temps?
put that in there with the ATF we're running
Yeah,
in the housing, you can turn that housing upside down and it isn't going to pour out.
right. But your components need to withstand that type of temperature,
Oh,
though.
for sure. Well, you think about that thick, it's going to warm up and start to flow rather quickly.
Right, yeah, so you get moving maybe a couple hundred feet or something,
and
and
it
it
starts
breaks
to
it
warm
up.
up very quickly.
Yeah.
And
But you still need to withstand that first period.
yeah.
Because a lot of people give like cars, combustion cars, like warm-up time when they're sitting still, but there's so many other components that still need to come up to operating temperature before you do something. So
Yeah,
that would be
your
an
transfer
interesting
case
example.
isn't spinning when you're warming up your engine.
Right, of course, yeah.
Yeah,
It's
so.
just not doing any good.
And then you get on the road and quickly it comes up to temperature and lubricates.
Yep, very cool.
So like you said, remember all those wires we had in the dynamometer?
Yeah,
Every one of those is wired to those 3 little wires off the pole.
really, that's it.
All 4 cells.
So that runs the entire situation.
Yeah, that's our primary power. It comes through the transformer and the switch gear into the building and then through all these cabling trays.
Yep. And those are beautiful trays that you've
Nice
created
and
there.
Very expensive.
Yeah.
It's pretty much the place. I don't know.
That's it. That's your tour.
Really?
What do you
That was
think?
amazing.
It was
Oh,
great
it's
to have
been
you.
an overwhelming day of just amazing things.
Cool stuff.
Yeah, no, it was really cool. That dyno room is insane. Thanks so much.
Thank
Really
you.
appreciate it. Well, I can't thank the team at Magna enough for inviting us over to their Powertrain laboratories and learning about all the cool projects they're working on. As sort of an EV nerd, it was my goal to partner with Magna so we can learn more together between you guys and me about how electric powertrains are developed, created, engineered, and put into place. We also got to learn about some combustion stuff, which I always find absolutely fascinating because as combustion vehicles evolve, they still need to get more efficient, which means more complicated and more stuff. It's just a wild world. So I know you guys have seen the ads of this video is brought to you by Magna for a few months now, but now we're actually getting into the nitty gritty, and I can't wait to bring you a whole bunch of videos going deep dive into how things are actually engineered for the automotive industry, and it's about to heat up. It's getting real spicy. So a huge thanks to Magna, a huge thanks to you guys for watching. Man, I'm pumped up.